This is the Pearson Edexcel Further Pure Math IGCSE June 2022 paper 2. Let's just go straight into it. So real roots means b squared minus 4ac is greater or equal to 0. Well, b is 5k, a is 2k, and c is 5k minus 3. So you put that information in, make sure that you square all of 5k so it becomes 25k squared. Expand this out carefully, don't make a mistake with the minuses. Simplify it up. And this has critical values clearly at k is either 0 or k is 24 over 15, which simplifies to 8 over 5. And now this is an upside down quadratic that you want to be bigger than 0. So think of an upside down quadratic, critical values here. Bigger than 0 means between the two critical values. So you're looking for this, except if you make k equal to 0, this turns into a non-quadratic. In fact, it just turns into minus 3 equals 0, which clearly isn't true. You're not allowed k as 0. It actually tells you right there. So therefore, the true answer is this here. They often use that at the very end to trip you up. So just be careful to look at this or look at the equation and make sure you get rid of the edge cases in case they don't work. Question 2, though, velocity is dx by dt. It's the derivative of the displacement. So let's do dx by dt. We get this. When t is 3, you just put t as 3 in there and you calculate it. When it's at rest means v is 0. So we're just going to make this, which is this, equal to 0. We're going to solve that by adding 13.5 divided by 4 and cube rooting. We get t is 1.5. And the acceleration is dv by dt. So the ladder goes x, v, a. Displacement, velocity, acceleration, differentiate to go down, integrate to go up. So we're going to differentiate this again, and we get this. When t is 2, you just put it in, and you get a is this here. Question 3 then. So this means, of course, the magnitude of OA is root p squared plus 4 squared, and the magnitude of OB is root 1 squared plus brackets 2p plus 1 squared. So I can just put that information in like this, and then just square both sides to get rid of all the square roots, and it looks like this. I've also simplified and expanded a few of these numbers in here as well. Of course, we can collect this all together on one side, divide by 2, factorize to find solutions for p at 3 or minus 5, but p is bigger than 0, so therefore p is 3. Using this value of p, find a vector that's parallel to AB. So AB is, if you imagine, an XY axis, OA is a vector, XY axis here. OA goes out this way, OB goes out this way. From A to B, you have to go back along the vector OA and then forward along the vector OB. So A to B is minus OA plus OB. That's the definition you'll see in lots of textbooks as well. Minus OA is just minus P plus 4, but P is minus 3, so that's going to be minus 3 plus 4, J. And then you put in p is 3 into here and you get this. And of course we can simplify that up. And a unit vector, now this vector is too long. The length of this vector is 2 squared plus 11 squared, which is this. So if I just scale this vector down by factor this and keep it in the same direction, I'll make a unit vector parallel to it. So I'll just scale it down and keep it exactly in the same direction by keeping these numbers here. And that'll be a unit vector parallel to AB. Question 4 then, they asked a very similar question to this in June 2022 of the non-IGCSE regular maths exam, where there were actually 3 circles. So anyway, this is interesting that they asked the same kind of question, although this one is a bit easier. This is clearly the radius of C1, this is the radius of C1, and so is this. So these are all length 6. But likewise, this is also length 6 because it's the radius of C2. Which means this is an equilateral triangle, just all sides length 6, which means this is 60, same argument on the bottom, and therefore this entire angle here is 120. Now, I think I can just work out the area of this segment here by doing the area of this sector, which is pi times r squared times angle over 360. That's the area of the whole sector, minus the area of this triangle here, which is a half times 6 times 6 times sine 120. That will give me this segment here. Of course, that's 36 times a third is 12 pi. This all turns out sine 120 is root 3 over 2. That's 9 root 3, I guess, and that turns out to be up. And that's this segment here. And of course, the grey area is just double that. So I'm just going to double that and I'll get my answer quite quickly. Question 5. So the roots add up to make negative this over this. So that's minus this over 2, which I don't think I need to simplify. And the product is this over this. Which is just this, which again, it hasn't asked me to simplify, so I genuinely couldn't be bothered. Show this thing here. So a minus b all squared is, I can write it like this, I guess. And then if I just add in 6 copies, or is it 4 copies of alpha beta, only to take them away again. I'll end up with this. And this itself factorizes back to something similar but more useful, which is alpha plus beta squared. And that's useful because alpha plus beta is this, and alpha beta is that. So I can now put those pieces of information in. This, of course, is just 3 minus p, or actually minus 3 minus p. But when I square something, it doesn't matter whether it's negative. So I just swapped out the signs because I could be bothered to square them. And you get this 2p over p is just p. And then you can clear this up and you'll end up with the right-hand side that they wanted you to get. Given a minus b is 3, that means this is 3. So 3 squared equals this. The 9's cancel. So either p is 0 or p is minus 2. And those would be our answers. Question 6, using the formula from page 2. These are the formulas. This one looks like the most helpful here. I can write it down. If a is equal to b, then we get this. Of course, this is just cos 2a. This is cos squared of a. This is sine squared of a. Cos squared of a is 1 minus sine squared of a. And this makes 1 minus 2 sine squared of a, which is what they wanted us to get. And now they want us to integrate this around the x-axis. So integral around the x-axis is pi integral of y squared between the two limits. So this is y, so I'm going to square it and then put pi in the front between the two limits. Expand that out, you get this. This is easy to integrate, this is easy to integrate, this isn't, but this is where I can use this idea. So if you put the 2 sine squared on this side, put the cos 2a on this side, and then double everything, I think you end up with this. So I can replace this 4 sine squared with this stuff here. The 9 plus the 2 make 11, and then I can integrate. So 11 integrates to 11x, this integrates to minus 12 cos x, because sine integrates to minus cos. Cos integrates straight to sine, and then the 2, you divide by 2 because of this 2 here, and you get this here. Good chance to practice your exact values here. This just makes obviously 11 pi over 4. Cos pi over 4 is root 2 over 2, so that makes 6 root 2. And sine of pi over 2 is just 1. And then the other bit, 11 times 0 is 0. Cos of 0 is 1, so that makes a minus 12. And sine of 0 is 0. And it's asked me to the nearest integer, but I don't want to do that because it feels wrong. So I didn't. Anyway, question 7. We've just done this, guys. Come on. So they want me to do this again. This one is the one that's useful. Just let a equal b equal theta, I guess. Put it all in. This is tan of 2 theta. This is 2 tan theta. This is tan theta squared. You get what they wanted you to get. Given tan 2 alpha is 1, so just replace all these with alphas. And then this becomes a 1. And you get 2 tan alpha over 1 minus tan squared alpha. Multiply this across. Rearrange to make a quadratic in tan. This, I think, doesn't factorize. So I'm going to use the formula. When you can make a substitution if you want, like x equals tan alpha, and then use the formula for x equals the answer. But why bother doing that when you can just say tan alpha equals the answer? This is just me doing formula. So it would be minus b, which is minus 2. B squared is 4, and then minus 1 times 4 is plus 4. Divided by 2 times 1, and this also applies. That's root 8, which is 2 root 2, which cancels with this, and then this cancels, and you get down to this here. Using the formula from page 2, oh my god, okay, so bring out the formulas one more time. So show this, well, this one here, I think is going to be helpful. So this is cos x cos 30 plus sine x sine 30. And this one here, we're going to use this formula in a very similar way. So I think I'm going to get this. Cos 30 is root 3 over 2. Sine 30 is a half. Do that a few times. I divided everything here by cos. So cos over cos just goes away. Sine over cos is tan. Sine over cos is tan. Cos over cos goes away. I grouped the tans on one side and the numbers on the other. And then this number here is the same as this number here. So you can cancel them out and just get tan x equals 1. This only works as long as cos x equals 0, but they weren't careful enough to make you say that anyway, so irrelevant. Hence, otherwise solve this. Here, I mean, the only difference is that x has become 2y, so therefore tan 2y equals 1 is what I need to do with this answer here. Looking between 180 and minus 180, of course, because you've doubled the argument here. Inverse tan to get 45, and then tan is just the one where you add 180 or take away 180 to find other solutions. So if you add 180, you get past this number. So take it away instead, you get this, and then divide by 2, and you end up with your 2 solutions here for y. Question 8 is, okay, so they've given me AB equals DC. I'm just going to label this all on the picture. AD is H, and so is BC. And then there's some more labeling to do, which is this and this. And okay, so, and then the top is such that this is H as well. So yeah, this is also H. The volume is this. Now the volume of this is the front trapezium times H. How do I work out the area of the front trapezium? Well, I need its height here. Now, if this is 8x all the way across and this middle bit is 2x and it's symmetrical, that means it goes 3x, 2x, 3x to make 8x. So this here is 3x And then you can just notice the 3, 4, 5 triangle, all times by x, so the height is 4x. You can do some Pythagoras if you really want to. The area of the trapezium, therefore, is 2x plus 8x all divided by 2 times 4x, just a plus b over 2 times h. And therefore, the volume is that also times by h, which is all equal to this, which is equal to 2250, apparently. Now for the surface area, which is 2 of these trapeziums, which we already worked out with 20x squared. So it's 2 of the trapeziums plus 2x times h for the bottom, plus these 2 parallelograms on the side, which is just area 5x times h, and there's 2 of those as well. That all simplifies to be, I guess, I haven't done that, I've gone back to volume. Volume is this, which means if I rearrange that for h, I get this. And now the aim is to put the h into the surface area bit. So whenever I see an h, and by the way, this is obviously 12xh here. So okay, yeah, I've said that, and then I put the h in here as well. The x's cancel to leave 1 on the bottom. This all cancels down to the number they have here, and we're done. Given x in vary, use calculus to find s as a minimum. I'm going to use horrific notation here and just write SA dashed to show that I've derived the surface area. I realize now they didn't even call it SA, they called it S, but who cares? This is 1,350 to the power minus x to the power minus 1. Bring the minus 1 down to make it here, and then lower it down to a minus 2. And this, of course, differentiates to dx. To find a minimum, I'm going to set it to 0. To solve that equation, times everything by x squared to remove this nonsense here. Move this to the other side, divide by 18 cube root, and you'll eventually get x as this. Justify it's a minimum, so if we differentiate this again, we'll end up with this here, because the minus 2 times minus makes a plus, and then this here. Put in this number here, and it ends up being bigger than 0, which means it's a minimum. And finally, to find the minimum value of s itself, put the value of x you've got into the formula for the surface area here, and we'll get the SA as this here. Good. Question 9 is the worst question on this paper by far. It's really fiddly, and I'm shocked that it was not the last question at the very least. L1 is y equals mx plus c. You're told the m is m, and you're told it goes through this point here. So I can use that information like this, x is 4, y is 7, to find an expression for c in terms of m, and then I can say L1 has this formula here, just in terms of m. Now L2 is perpendicular, so it has gradient minus 1 over m, and passes through these coordinates. So I'll do the same thing. I'll put in x is 4 and y is k, and rearrange, and I'll get this, which turns out to be this equation here for L2. Okay, now they intersect at point C, and the y coordinate of C is big Y. So it's no use just letting me set this equals this, because then I lose the y. So I need to rearrange these both for x, which looks like this and this. Rearranging for x. You can do it in your own time if you need some more time to do that, but rearrange for x, and now set them equal to each other. And now the y's have got to turn into big Y's, which is only helpful because that's what I've been asked to show to do. So I would never do this otherwise, but I'm being asked to show it directly like this. So I get this here, setting these equal to each other and setting y to be big Y. If you do some expanding out and multiplying out and stuff, you get this. If you put all the y's on one side and all the other nonsense on the other, you get this. The 4m's helpfully cancel. Factorize out the y, also times everything by minus 1, I guess. And then finally divide by m squared plus 1, and you end up showing what they wanted you to show. Last bit of the question is very fiddly. Given ABC as isosceles, so at this point I decided to draw this because I have no idea what's going on. I've got a point 4,7 with a negative gradient line going through it. So maybe 4,7 is like somewhere over, I don't know, somewhere here on this line. I've got another line which goes through B, which has coordinates 4k. So that's directly above or underneath this point here. I've said that it's underneath, although maybe I've said that it's above, because like if 4k, okay, let's say 4k is, I realize at this point that the picture you're about to see is wrong, but it doesn't matter at all, so I think I've got away with it. But let's imagine 4k is here and 4,7 is here. So okay, that's the 2 points there, and then I've got the third point where the 2 lines intersect here, which has a y coordinate this, apparently. Now, the distance between those 2 points, I've said is k minus 7. Now, I realize at this point that it's probably actually 7 minus k, but it doesn't matter because it's a distance, and distance doesn't care about signage. So I think I get away with doing it like this. I wasn't really thinking it through when I did it, I guess. But in any case, where am I going with this? Well, ABC is isosceles. Now, this is a right angle, remember, because these 2 lines are perpendicular. And now if this is a right angle and this triangle is isosceles, it's a right-angled isosceles triangle. And the only 2 sides that could be equal are this one and this one, because the hypotenuse cannot be equal to the other 2. So these two sides are equal. That's not especially helpful, but what is helpful is knowing that this triangle is symmetrical and has a line of symmetry down the middle like this, because it's isosceles. So therefore, if I start here and pretend this coordinate is the point 7, I realize at this point I've drawn the whole thing upside down. It doesn't matter. Pretend this is 7 and this is k, and k is the bigger value. It doesn't matter. The picture now goes wrong. What I'm going to do is I'm going to say 7 plus half of this distance here gets me to this y coordinate here, which I've already tried to figure out here. So this is what this expression says. It says that the y coordinate at this point, which I'm pretending is 7, even though the picture is drawn wrong, it doesn't matter. The y coordinate at this point, 7, plus half of this journey here, because of the symmetry in the triangle, gets me to the y coordinate of that there. So I can write down this expression here. Now, if I do some fiddling around with this, I think I can do some more stuff. I eventually got this by doubling everything. Now I can finally expand it out. This makes a double brackets to expand, remember? Just be careful. And now this, I have no idea where this is going, but it actually turns out to be okay in the end. You eventually end up with this. And you're supposed to solve this for m. And this just about works. I have no idea how you're supposed to spot this in any reasonable amount of time, but this just about works if you factorize out the m squared and leave behind k minus 7. And then say that here, this is just 1 into k minus 7, or 7 minus k. When you divide both sides by k minus 7, because k isn't 0, 0 divided by it goes away, is nothing, it doesn't matter. M squared divided by it just becomes m squared. And then this becomes a minus 1, and then you get m is equal to plus or minus 1. But they've told you m is negative, so therefore m is minus 1. That question is disgusting, and I have no idea what it's doing here. It's not, I had no idea where I was going with this at all. And I feel like the only reason that I continued with it is because I've done horrific stuff like this before and sort of just decided that it might work. I can't imagine the number of people who just gave up the moment they got, even if they thought to do this, which is not an easy thing to spot at all. I don't understand how they were expecting people to get all the way through this. But anyway, they then provided two very nice questions at the end of this paper, which is even more confusing. Use the Taylor-Swift change of base law here, which says that log of some value to some value is log of whatever value you want twice to this value goes here and this value goes here. So for example, log to base 4 of x. This is acting as 4, this is x, so it becomes log to base whatever I want with the x here and the 4 here. Of course, I'm going to choose log to base 2 because log to base 2 of 4 is 2 and log to base 2 of 16, I've used the same trick on this here, is just 4, and you end up with this. A quarter of this plus a half of this plus 1 of this is 7 over 4 of it. 10.5 times 4 is 42. Divided by 7 is 6. And then you just raise both sides to the power 2, and you get x equals 2 to the power 6, which I guess is 64. And you'll get the question right. And last one, you get given the quotient rule in the formula book, so you just square this one on the bottom to make ax minus 6 all squared. You differentiate the top, which just becomes 2a minus 1, because that's just the number in front of x, and then times it by what's on the bottom, which is this here. And then you take away, leave this alone, that's just the original function, leave it alone, and the derivative of the bottom is just a, so I put it there. And they haven't asked me to simplify, so I think that deserves 4 marks. The curve crosses the y-axis at the point A. The normal has equation this. So okay, what I'm going to do is I'm going to find, crosses the y-axis means x is 0. So let's put x is 0 into this. That goes away, we just end up with minus 6 lots of this. That all goes away, so you just end up with a minus a at the end. And this just becomes a minus 6 squared, which is 36. So okay, that's the derivative of x equals 0. The normal is this here. This means that the gradient of this is the negative reciprocal of this. So, okay, the gradient of this is 72 over 66, which is 12 elevenths. So therefore, the gradient of this curve at the same point is minus 11 over 2. So I'll set this thing here to be minus 11 over 2 because they're normal to each other. Divide, I think I cancelled out a factor of 12 here on the bottom and then started multiplying across. I cancelled all the minuses as well just to make life easy. 13a minus 6 is this, plus the 6 is 39, divide by 13 to get a is 3. So that's showing that, and then you get 1 mark for just putting a is 3 into here. I don't really know what they expect you to do to pick up the mark here, because they've told you the answer, so sure. Using the axis on the opposite page, sketch C. So okay, we've got an asymptote at x equals 2, because if you put 2 in here, you'll be dividing by 0, so that's one asymptote. You've also got an asymptote at 5 over 3. More specifically, y equals 5 over 3. Now, the reason that exists is because if you use y as 5 over 3 and try and cross multiply, 5 over 3 times 3x is just 5x. minus 6 times 5 over 3, I guess, is what, like 10? But then the 5x cancel, and you just end up with like minus 10 equals 1, which isn't true, so that can't work. So therefore, y equals 5/3 is also an asymptote. And it also wants the coordinate square across the coordinate axis, so let's use x equals 0. And if x is 0, you get y as 1 over minus 6, or just minus a 6. And if you use y as 0, you cross multiply, this just goes away. You get 5x plus 1 equals 0, so x is minus 1/5 as well. And now these curves always just look like two C shapes in opposite quadrants around the asymptotes, so it just looks like this and this. Good. The line L meets C again at the point D, finds the x coordinate of D. So we're just going to set this equal to the original line, which is this here. So if you rearrange this line in terms of y, I guess, and then just set this equal to that, there's a bit of solving to do here. It's not that fun. I think I brought these two things together, which is probably why they didn't simplify it. It doesn't really matter. Anyway, brought them together. I think I factorized out the 3 here simply so I could cancel a 3 with a 22 there. And that makes the numbers a bit smaller. Expand out, expand these two bits out properly. The 22's cancel, which is fantastic because that gives you a solution at x equals 0, which is correct because remember that was the whole point of this line, was it was normal at the point x equals 0, so they intersect at 0. So that's useful that it does that. X equals 0 is the one we already knew, so the other coordinate is x equals 265 over 72. That's the entire paper done. Thanks for watching. I'll see you next time.